Welcome to the Internet Report, where we uncover what's working and what's breaking on the internet and why. So there was a number of things that happened last week. One of them was an issue that some users experienced with Twitter. That was on the 16th, and that appeared to be related to an application issue. We're not going to really talk about that today. We're going to get into a really interesting BGP leak that occurred again on the 16th. And to discuss that, I'm joined by Kemal, who's a principal engineer with our customer engineering team, and we're going to dive right in. Kemal, welcome.
Thank you, Angelique. It's good to be back on the Internet Report. Awesome to be here.
And Kemal is, really kind of an expert on BGP, and so it's going to be an interesting discussion to kind of walk through. So, for those of you who are not aware, there was a pretty major BGP leak that occurred last week, and it came about because Vodafone started advertising, or had leaked, more than 30,000 prefixes. So that's pretty big. And this was Vodafone India. And as a result of that, there was some issues with traffic getting disrupted. And this happened around, this was 1:50 a.m. UTC. Is that right?
Yes, that's correct.
So 1:50 a.m. UTC, and then so that was like 9:50 a.m. On the East Coast. And in this article that we see here, it was reported that the incident lasted approximately 10 minutes. Now, what we saw was that the issue was actually lasted quite a bit longer than that. And to kind of walk through that, we can move over to this example that we have here of prefixes that are advertised by Akamai. So Akamai is a very large CDN provider, and they host traffic for host content for their customers on their very large global edge network. And so we can see here at the time that we have, this prefix here is being advertised by Akamai. And then at the time of the incident, so we have here between 9:45 and 10 a.m. Eastern time, so it's roughly 9:50 when the incident started, we have two origins that are now in the mix.
That's correct. So what's happening that's quite interesting in here is the fact that we are seeing now Vodafone India Ltd 55410 ASN stepping into the action and actually starting to advertise the Akamai's prefix that you just mentioned. And we can see that prefix propagated through the rest of the Akamai's network, hitting the rest of the tier 1 providers and basically propagating to the internet, and it had a pretty wide negative effect on all of the monitors that are in this particular screen seen on the left-hand side, indicated by red color here. As you can see here, Angelique is focusing on London-25 collector, and we can see that the prefix 2351.280/22 is now getting advertised by 55410, and then with your Vodafone Group PLC ASN as an upstream of 1273 before hitting Hurricane Electric here.
Right. So we're kind of zeroing in on this BGP monitor that's connected to Hurricane Electric, because Akamai has a huge number of peers, and most of the peers that we saw earlier when we were looking at all the monitors, not all of them either received or accepted this illegitimate route that was being propagated by Vodafone. But Hurricane Electric was one of the service providers who did. And so we're looking just a little bit more closely at them. So to kind of go back in time before the incident, again, you can kind of see Hurricane Electric is peering directly with Akamai. Akamai, is the origin, as we can see here. They are the legitimate owner, if you will, of this particular /22 that we see here. And if we go forward in time, we can see that there is some changes that took place. At this time, they're accepting a route from Vodafone, and they're effectively decommissioning this route to Akamai. So it looks like there's some route flapping that's taking place, and we can kind of see that, you know, it's kind of flipping back and forth between those two two origins, if you will. So
that's correct. And if we see details of the path changes, you can see exactly what we just spoke about. So on the right-hand side, because the ASN paths work that way towards the left-hand side, you can see that 16625 is the origin, and they are advertising their prefix to 940 before reaching the Hurricane Electric, and then at 095442 EDT, that switches to 55,410, which is Vodafone India Ltd advertising prefix to their upstream, which is Vodafone Group ASN 1273 before the prefixes reaches, again, Hurricane Electric. So we see this kind of flap.
right, and then, you know, we kind of see the flip side of that in the next round, where, you know, if we look at the details, it's flipping between these different origins. And so it's kind of interesting because, you know, there's basically two different paths that are being advertised to Vodafone from its peers. Now, would there be a reason why they would, you know, why both of them would be legitimate? Like, were they, you know, it looks like there's flapping between them, but you know, why wouldn't they accept and have both of these installed at the same time?
That's a quite good question. In fact, all of these changes that we can see here are determined by something that we called BGP best path selection algorithm. And that's basically the criteria that BGP is using to define which prefix is going to get installed in the routing table. And in this particular case, which is quite interesting, we see that all of the prefixes have 3 ASN in the S path, which basically from that perspective makes them eligible, right? However, though this behavior is part of which Vodafone India Ltd 55410 is hijacking the prefix, which changes the origin. The path itself is not the legitimate candidate for ECMP multipath, which rules it out basically. So what's happening here is that in general ECMP scenario, if the origin was the same, you would have two different paths to the same origin. And as a result of that, we would see some hashing, as part of which certain flows would go to path A, so to say, and certain flows would go to path B. However, given the fact that the origin itself has been changing here, this doesn't make it candidate for the ECMP, so BGP rejects that, and only one and single prefix is being installed at a time, even though the ASN path is exactly the same.
Right. It's really interesting how there's basically kind of a mixture of different things that are influencing this behavior, because the first thing that happens is that it's receiving a route that is the same path length. So if it was a longer path length, then it would just prefer the original route advertised path, in this case, Akamai. If it was shorter, then it might prefer that path. But because they're both equal length, it's basically switching between them and just taking the one that it's received, you know, it's most recently received, right? But to your point, if they did have the same origin, then they would effectively load balance across them, right?
Exactly. There are some other criteria for the path to be the ECMP candidate, but in general, like, you are 100% spot on. Like that, likely they would be a good candidate for ECMP here. So what we are seeing essentially here is traffic that's coming. So basically, Vodafone is advertising someone else's prefix, and it propagates over the internet. And in this particular case, we are showing the example of the Hurricane Electric, right? But the thing is, like, all the traffic that's being sent and that was installed in the routing tables on the routers on the pod. And the flows that were using those pods were essentially being black holed at the target, because the target itself didn't have the resources or services to serve that traffic.
Right. So any traffic that went down the path that was being advertised by Vodafone, because they didn't actually have a destination within their network, you know, that basically matched where the traffic was destined, it would have just all gotten dropped. And it's interesting. You know, we've been talking a little bit about like route leaks, and you know, there was also in the article. They call it a leak. Some folks might call it a hijacking. There's different takes on what qualifies as a leak versus a hijacking, right? In some cases, you know, I guess the very traditional thinking is that if it's unintentional, if there was no intent to you know, collect the traffic or have the traffic steered towards you, then it's sort of a leak. And if it's a hijacking, if it's sort of malicious. And then there are other folks that say, well, if the result is the same, you know, and you're advertising yourself, you know, as something that you're not, and the impact is that you're kind of effectively taking somebody else's traffic, then, you know, it kind of doesn't matter. It's still a hijack. But either event, it's just a word, right?
Yeah, the thing is, like, route leak versus hijack is just intent, right? Now, it's really hard without root cause analysis that are going to be published by the service provider, hopefully, to identify whether this was a leak or hijack, right? And most probably just based on the fact that this is company that's in the market for a long time. They are doing transit stuff. This looks to me like a configuration error. Some analysis are showing that basically there was a 30,000 prefixes that were affected, and they are indicating that there was a 3-time prepend of their prefix 55410, which indicates that this could be potentially something related with the RFC 9098, which is the traffic engineering RFC using communities. This is obviously just a wild guess. We don't know whether that's the case or not. But in general, like, I don't see why Vodafone would have malicious intent, right? But I do agree with your statement about whether it qualifies as a route hijack. In the end, legitimate customer traffic was affected by this, and as such, it's not really relevant whether it's a hijack or a leak. People at the end of the line got affected, and that's what matters here.
Yeah, it's interesting too, because, you know, you bring up traffic engineering, and one thing that we've seen in some other hijackings is that, and typically the reason or the cause of the leak or the hijack is because they're using some BGP optimizer, and they're kind of like splitting the traffic within their network. And so they might be, you know, we've seen, for example, some folks might advertise like a /21 or a couple of /21s for like some of Cloudflare's prefixes. And so oftentimes what's happening is that a more specific announcement is being made. And then what that does is that steers all of the traffic to the person who's making the illegitimate announcement. But we don't see that here. So Vodafone did not announce more specific prefixes. They were announcing the same prefixes as Akamai. So, you know, that basically creates a different situation in which, depending on the path length, you effectively have kind of two competing routes.
That's correct. So in general, like advertising more specific prefixes is one of the strategies of fighting route leaks and hijacks. Like, it's the same measure for both of them. And to your point, we saw I think late last year, we saw some of the BGP optimizers issues, as part of which large portions of the internet were affected, right? And that we don't see that here, right? We don't see any more specific prefixes being advertised or something down those lines. It's just the same prefix advertised by a different provider. And how it propagates is going to highly depend on how well the Vodafone India Ltd was peered with the rest of the internet. Because at the end of the day, the shorter IS path always wins, right? And depending on how well they are peered with the rest rest of the internet, that's going to directly affect how many customers are affected in this particular case.
Right. And in this case, it could have been a lot worse. The fact that Akamai is very densely peered with a lot of the major transit and service providers, and more so than, say, Vodafone India, that it didn't seem to have had as wide an impact as it could have had. But, you know, like we said, it was very long standing for a leak. I mean, typically what we see is they'll only be like, you know, 5 minutes, you know, they're pretty brief. But this one, we see this flapping taking place. And what's interesting here is that, you know, we have, you know, again, kind of this, you know, this flap here. And then in this next, so just look at the detail here. So we have 16,625, so Akamai, and then we see at 10:26 Eastern time, again, Vodafone India advertising the path. And then in the next round, we actually see basically a withdrawal, right? So 55,410, the last time we see the advertisement here is at 10:40, right? So it's almost an hour. And then we see the withdrawal 10:43. And then finally, you know, that goes to the next round. And then, you know, we see the last advertisement from Akamai, and then that's what kind of stabilizes the situation.
So yes, it almost lasted 1 hour based on the data that we have in front of us. It's quite interesting to see some of the early analysis that were published on the internet regarding this particular event, which indicate that, and we can see that a majority of the path changes did happen in the first iteration of the event. So at that was 9:45 EDT, right? And these early analysis and blog posts that are published about this event indicate that it lasted for 10 minutes, and it did probably for a majority of the prefixes that were affected. But as visible here, some of the prefixes had this ongoing for a good 1 hour, which is quite interesting from the impact kind of perspective.
Yeah, absolutely. And, you know, just on that point, in terms of the impact, I mean, we can see that here, you know, kind of like when that big announcement kind of change or path changes happen, and then kind of the immediate aftermath, we see that there's packet loss. So, you know, the DNS is still resolving to, you know, this is Akamai, but we see that there's, it's not reachable, right? So traffic is getting dropped, and this is actually getting black holed in Vodafone's network here. So it did have an impact on traffic flows, as we can see. And so, you know, it is interesting because it's kind of important to know, you know, not only what your dependencies are from the standpoint of, like, if you're a customer of this CDN provider, for example, there may be other things that you would want to know and that could have prevented this. Because it's interesting because, you know, we were discussing this. I mean, you know, could this have been avoided, right? Like there's, you know, RPKI that could potentially have prevented this. And Hurricane Electric has actually adopted RPKI. So, you know, why did they accept this illegitimate route? So we were talking about this, and actually there's a different reason why. It wasn't anything to do with Hurricane Electric. It actually had to do with Akamai's prefixes.
Exactly. So to your point, this could have been avoided. And I feel like this is a repeating pattern when it comes to root leaks and hijacks. It's always, this could have been avoided, but it's actually a question of whether the companies, service providers, tier one providers are taking necessary steps to mitigate a potential for this kind of impact, right? So to your point, we were discussing about the prefix 2351.208.0/22, and that's the prefix that belongs to Akamai ASN 16625, and we can actually verify that, right? So in order to verify that this is what's actually happening, we can verify that this prefix 2351.280/22 actually belongs to Akamai. So in order to do that, there are multiple ways, obviously, to do this. But what I intend to do is I intend to use simru.com. So who is -age with simru.com -v and as sorry, it's just a prefix. So as you can see here, Simru is giving us who is data for this BGP prefix. So we can see that 235128.0/22 belongs to 16625, which is obviously Akamai in US. So now what we can do in to check or whether this prefix was good candidate to be protected by RPKI, we can check whether the ROA for it exists. And ROA is just a combination of prefixes along with their ASN. So this is a command to do so. We can use this one here. So who is -h to who is BGP Monad, and we are basically querying ROA for 16625, which is an ASN for the prefix that we just discussed. And we can see that the prefix itself is not found, which indicates that it's not signed, which then answers the question that you raised a little bit earlier on why this prefix wasn't protected. It wasn't protected because it was not signed, and even though the Hurricane Electric implemented it in June, this prefix wasn't just a candidate for it. So,
right. So if the prefixes were signed, then, you know, like Akamai would have looked it up. They would have seen that the announcement they were getting from Vodafone India wasn't associated with that prefix, like that, you know, that they weren't the ASN in the record. They didn't own that prefix, and they would have just rejected that announcement. So
exactly.
It kind of takes two, right? It's sort of like DNSSEC, where it's not just a matter of like, you know, the service provider implementing it. Has to also be the owners of the prefixes, and the combination of the two is what enables the protection.
Exactly. So here, the other thing that, so yes, first of all, RPKI can be used to protect from these cases. It's created for exactly this purpose, and it's one of the building things up that are part of the manners framework. Besides that, some of the other things that could be used here is, for example, Akamai advertises a certain number of prefixes to their upstream providers, and if there was a filtering on the edge implemented in those providers based on the maximum number of prefixes, they would be dropping. Now, I understand that this is a little bit different case for the max prefixes, given the fact that Vodafone originated it, and it, based on some indications in this case, we saw it propagating to Hurricane Electric, which is again a company that does transit, right? So as part of that, it's not realistic that you would have max prefixes filtering on these particular BGP sessions. However, filtering based on the AS spot that's originating this prefix, basically proper filtering based on the publicly available information in RootDB and stuff like that, would have potentially prevented this thing. The problem with all of these in general is that they are best effort, right? If you think about max prefixes, max prefix would work. And again, it's not that it would potentially work in this particular case, just based on the nature of this particular leak, because Vodafone is advertising pretty large number of prefixes. So does the Hurricane Electric, Bharti Airtel as well, that's heavily involved in this particular event. You know, they are in the transit business, and they are exchanging full routing tables. So max prefix is not something that I would expect to see that kind of filtering there. However, what I would expect to see would be a proper implementation of filtering, but that being best effort, it did not happen. Again, even though Hurricane Electric, in the example that we just saw, did best practice on their side, they are basically participating from June last year in the RPKI signing, and they are validating prefixes and stuff like that. This particular instance of scenario suffered just purely because of the fact that not everyone participated, and if the Akamai signed their prefix and created ROAs, this wouldn't have happened. At least it wouldn't have happened in the format that we just showed.
Right, right. Well, and just to contrast, you know, an affected service like Akamai, So if, for example, Vodafone, had leaked routes to Cloudflare to Hurricane Electric, right? What would the impact have been, right? Because now, we know Cloudflare is fairly vocal in their championing of RPKI, and I would expect that they have their prefixes signed. So the combination of Hurricane Electric validating, RPKI and Cloudflare having implemented it, it'd be interesting to see if we can see
Yeah.
that they have signed.
So basically, what am I doing here is I'm checking DNS resolution for cloudflare.com, and as you can see, we are basically getting multiple addresses for their DNS records. So they have quadruple A, and MX handlers here. If we take this prefix, for example, and we check it again with this same whois query that we did previously. So we can see that this particular IP address 104.16.132.229 is the part of the Cloudflare ASN 13335. So now if we execute the same command that we were executing for the Akamai prefix, you can see that 13335 ASN is in fact using signatures. So 16.128.0/20. And as you can see here, there is ROA created for this particular prefix. So first of all, we are getting that it's valid. We can see that origin ASN is Cloudflare's ASN. We can see validity data. We can see who is trust anchor that signed this particular ROA. And you can see that's exactly the prefix that we just looked up. So if this if this particular prefix was leaked or hijacked by someone and advertised as a consequence to the provider that does RPKI validation and verification, this wouldn't have happened, right? Because they would validate the origin ASN would be different, like basically in case of example that we earlier showed, we saw that that was 55.4.110 Vodafone, and as you can see, origin for this particular prefix is Cloudflare's ASN. So there would be difference in the origin ASNs, and as a result, all the participants that are doing verification for the signed ROAs would just drop this.
Right. And so, if you had done that same query and just popped in Vodafone's ASN instead of Cloudflare's and done the lookup, it would have come back as invalid, right? And that's what Hurricane Electric would have seen. And then at that point, they would have rejected the route. So it's, there you go, not valid, invalid origin ASN. So, this is, it's sort of a, kind of speaks to the fact that when it comes to security on the internet, it's really kind of requires a community effort, right? Like all of the service providers and whether they're transit providers or ISPs or they're application providers or infrastructure hosting providers, they all have to kind of participate in order for, there to be safety, across the board, right? So it is becoming much more widely adopted, but as we can see here, it's not.
Yeah, there's a significant push to get ROA, RPKI and ROA signed. I know that anchors are doing pretty good jobs, a pretty good job on it. There are certain companies such as Cloudflare that's doing pretty good job on pushing the internet forward when it comes to signing their prefixes and ASNs. And the thing is, like, the faster we get there, the better it's going to get for everyone. In general, like, I do understand that's a hard step to take initially. Changes are hard. In general, like they require resources, they require people. There's always this element of whether this is going to be causing potential outages and stuff like that. So there's a fear factor. However, once people get over those hurdles and do adopt it, it's going to get better for everyone. So just be a good neighbor and implement.
Right, absolutely. Okay, so well, that's our show. We went, pretty deep on a really fascinating topic, BGP. If you have any suggestions on future topics or want to drop us a note with any comments, you can reach us at internetreport@thousandeyes.com. And of course, if you subscribe to the show, you can get a free t-shirt on us. We have some pretty cool t-shirts. So subscribe and then send a note to that email address with your size and your physical address, and we'll get it right out to you. So with that, have a great week.